So this is the first video for the trigonometry chapter. In one way it is also the last video of the triangle semblable chapter, because in this particular video we will be looking at similar triangles for the most part, and then I will briefly introduce to you what trigonometry is. In the next video we will get into trigonometry in detail. So we have two similar triangles here. I have drawn them. ABC, DEF. Angle A est égal à 60 degrés, angle D est égal à 60 degrés, angle B est égal à 40 degrés, angle E est égal à 40 degrés. Donc, comme il y a deux angles égaux, deux angles égaux, 2 par 2, ces deux triangles sont semblables. So, two similar triangles. We know from Thales's theorem of proportionality and properties of similar triangles that DE sur AB, DE sur AB est égal à DF, DF sur AC est égal à FE sur CB, FE sur CB. These are the ratios of homologous sides, because this side is homologous to this side is homologous to this side, and this side is homologous to that side. You take the ratios. If you actually calculate them, this is equal to K, which is the ratio of agrandissement of these two triangles. So you apply that ratio of agrandissement to this triangle, you will come to this, you will get this triangle. Now, this is all that I have said so far. We already know, we have covered it in detail in this last chapter. But let's go a little bit more into depth, and we will then do something to these equations. How many equations are here? Actually there are three equations. This is equal to this, one equation. This is equal to this, second equation. And this is equal to this, third equation. So there are actually three equations here, even though there are only two equal signs. So we will take these three equations and we will get something interesting from them. So let us see first. First we see that in this set of equations, the numerators are all from this triangle, DEF, FE. The denominators are from ABC triangle, AB, AC, CB. This is the way it is. It's the ratio of sides, ratio of the lengths of sides 2 by 2 of similar triangles. But let's take this first equation, DE over AB is equal to DF over AC. So we write it here, DE over AB is equal to DF over AC. By simple algebraic manipulation, we can multiply both. What we are doing is we'll move AC over there and we'll move DE over here. We will exchange DE and AC. Now, move and exchange are not really mathematical operations, but what we are doing in effect is we are multiplying both sides by AC. So when I multiply this side by AC, AC gets cancelled out and I get AC there. And both sides I am dividing by DE. So when I divide this side by DE, DE gets cancelled out here and it comes here. So we get AC over AB is equal to DF over DE. So what it means is AC over AB is equal to DF over DE. Now you see, very interestingly, here we had all the numerators from one triangle, all the denominators from another triangle. Here we have separated it out. This is from triangle ABC, this is from triangle DEF. What this means is that for any triangle with these two angles, 60 degrees and 40 degrees, this ratio over this ratio, the ratio of this side over this side is equal to the ratio of this side over this side for any similar triangle, and this applies for any two similar triangles. So that means, and similarly, let me first finish for that, we'll take this equation, DF over AC is equal to FE over CB, dF over AC equal to FE over CB, and we'll come to that again. If we exchange these two terms, we'll get CB over AC is equal to DE over DF. I'd written it wrongly there. I wrote it in red, corrected it, DF. So essentially again you're getting the ratio CB over AC. Where is CB? CB over AC is equal to FE over DF. CB over AC is equal to FE over DF. And similarly, when we take the last equation here, DE over AB is equal to FE over CB, DE over AB is equal to FE over CB, and we exchange these two terms again, we'll get CB over AB is equal to FE over DE. If you like, you can pause here and look at all of this as well as this, just to make sure that you've understood what I've done. Now when you have this, again, if I take it, CB over AB, that is CB over AB is equal to FE over DE. So now that we have this, let's go to the actual calculations. So what I did was I took this as 50 millimeters. I drew it 50 millimeters, and then I measured these two sides. So this I took par hypothèse 50 mm. These two sides I measured with a scale. So I get AC over AB is equal to 31 over 50 is equal to 0.62. Then I took CB over AC, CB over AC, CB over AC, I measured this is 45, that is 31, so you get 45 over 31, you get 1.45. And then finally CB over AB, CB over AB, 45 divided by 50, you get 0.90. Now, what it means is these three ratios are fixed for any triangle which has these two angles in it. So I could have given you this to begin with. Without showing you all that I have done, I could have said if I have ABC, one triangle with 60 degrees and 40 degrees, for a triangle A is equal to 60 degrees, B is equal to 40 degrees, C is equal to 80 degrees, because that angle will equal 80 degrees. 60 and 40 are 100, add up to 100, 180 minus 100 is 80, and that these ratios will always be true for any triangle with these angles. Now it will be useful that if you are given any one side and these three angles, then you can calculate the other two sides. So let's take an example. I have a triangle DEF with the same angle 60, 40, 80, 60, 40, 80, same as that, 60, 40, 80. Just to keep it simple, I am not switching it, I am not rotating it, just keeping it in the same orientation. And I say DE is equal to 80 millimeters. Then what is DF equal to and what is FE equal to? Now because these ratios are fixed between the sides for any triangle which is 60 degrees, 40 degrees, 80 degrees, you can calculate it. You know DF over DE is equal to 0.62, DF over DE is equal to 0.62. I am taking homologous sides. DF is homologous to AC, AB is homologous to DE. So you say DF over DE is equal to 0.62. DE, so DF is equal to 0.62 into DE, 0.62 into 80, because DE is given as par hypothèse 80. So you multiply this, you get 49.6 millimeters. Similarly, to calculate FE, FE is this, that is CB here. So we can take CB over AB. FE over DE is equal to 0.9. CB over AB is equal to 0.9. FE is equal to 0.9 into DE. 0.9 into 80, we get 72 millimeters. So essentially, given these ratios for a triangle of this with these angles, you can always find out the length of the sides given any one side. And why did I choose 80? Because I had drawn this as 80 here, and if you see, it is 80 here. I had drawn it, and we found our DF is equal to 49.6, that is 50 millimeters. So if I measure DF here, you will see it is just under 50 millimeters, that is correct. And when we come here, you see that FE is equal to 72 millimeters. So if I measure FE, you see it is close to 71 millimeters there. Okay, so what have we done so far? In these 11 minutes of the video, I've shown you that not only the ratios between triangles are fixed for a given set of angles, that is given similar triangles, but the ratios between two sides of the same triangle are fixed. This over this is equal to this over this. So this is the basis of trigonometry. Why have I gone to all this detail? Is because this is the basis of all of trigonometry. So now I'll give you two homeworks. One is here you have KLM, one triangle, similar 60-40, 60-40. ML, this side I give you is equal to 40 millimeters. What is KL and KM? KL and KM. I've written MK here. So these two you calculate. Now, and the second one is that I give you another triangle, 30 degrees, 50 degrees. This is not similar to this triangle. It is a completely different triangle, 30 degrees, 50 degrees. That adds up to 80 degrees. Z will be, well, you'll calculate Z if you need to. So I want you to find out the ratios of XY over XZ, ZY over XY, and ZY over XZ. So these three ratios I want you to calculate. How will you do that? How did I do it here? I took a random number, 50 millimeters. I drew this with these angles, and then I measured those two sides. So that's what you do here. You draw this triangle, and then you measure the three sides, and you calculate how to get it in focus. And then you calculate these three ratios. Okay? Right. So far so good. But if I given you these three ratios for this triangle, what if we change the triangle a little? Instead of 60, 40, 80, if I made it 60, 41, 79, all these ratios will have to be recalculated. I will have to draw them like you're going to do for this one. I will have to redraw, calculate, and write down the values. So, how many different triangles we can have with different angles? Well, the simple answer is we can have an infinite number of triangles, because if you have 60 here, you could have 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees. With each one of those, you could have 1 degree, 2 degrees, 3 degrees, 4 degrees. So, and why only going up in whole degrees? I could even have 1.5, 1.55, 1.53. So there's an infinite number of triangles, and so we will have to find out an infinite number of ratios, so that just to solve a triangle, by solving I mean finding, like we solved this triangle, given one side, find out the other side given the angles. We will have to use these ratios for an infinite number of triangles. Where would you find these ratios? They won't be printed in a book. So you will have to calculate, redraw individually. So what I've shown you is impractical for a random triangle like this with angles with angles that can be of any value. But this whole thing becomes extremely useful when you take a right triangle. What is a right triangle in French? Triangle rectangle. So, trigonometry, now we come to the definition of trigonometry, is a branch of mathematics that deals with ratios of lengths of sides of right triangles. So here, this is it, ratios of lengths of sides, but this is not for a right triangle. Trigonometry deals with ratios of lengths of sides of right triangles. It is extremely useful in science and engineering and even in other mathematical fields. So, it is a very basic thing, and essentially you have that because a right triangle is defined, see here, to define a triangle, I have to specify two angles. In a right triangle, by default, by hypothesis, one angle is already defined for you, that is this angle. So if you define one angle, let's call it theta. What do you mean theta? Theta is written and spelled like that in English. It's a Greek letter. It's often used for, it's a letter of the Greek alphabet. It is often used for angles. Instead of ABC, sometimes they use theta. So if I say I have a right triangle with a particular angle, say if I said if theta is equal to 30 degrees, then the triangle's angles all are defined because we already know this is 90. If this is 30, then that will be 90 plus 30 is 120. 180 minus 120, this will be 60. So once you define a right triangle and give any one angle, then all the angles are known. Instead of finding out this angle and this angle, if I just give you this angle, that angle is easy to calculate because it is a right triangle. So in trigonometry, these three ratios have names. Those names, as you know, in French are sinus, cosinus, et tangente. And that will be the definition of these three ratios. What each one means is the topic of the next video. So this is where I end. I hope you didn't get confused about all of this. Do this and send it to me to prove that you have actually watched this video. I stop here. The next video will be actually going into utiliser la trigonométrie du triangle rectangle. This is actually a little title that is a little wrong because trigonometry applies to triangle rectangle. It's a bit of a, they don't really need to say du triangle rectangle. An interesting aspect of trigonometry is that if you take any triangle, you can always break it up into two right angle triangles. You just drop an auteur from one of the sommets to the opposite side and you get one right triangle here, one right triangle here. So any triangle can always be broken up into two right triangles, and that is where trigonometry comes in extremely useful. That will be the topic of the next video. I stop here.